Good morning, everyone. I'm Shota Olusegun. In today's video, I want us to look at the anatomy of quantum gravity. Where you will recollect, if you have watched some of my previous videos, that I said quantum has its own gravity, and then classical has its own gravity. But as they move towards the central 0 point, which is singularity, both the classical gravity and quantum gravity will actually be fused together, and so we may have a definition for quantum gravity. So I'm going to define quantum gravity as I deem fit here, and then we use a time energy wave model to illustrate the fusion mechanism of classical gravity to quantum gravity to justify that. So now, when you look at the board, first of all, I want to define mass, and then later we're going to define quantum gravity. Now, mass can be defined as a convergence against repulsive interaction of time energy tapestry to form the potentiality of mass worth. Well, the reason I use mass worth here is for the fact that when mass is being extended by the virtue of relativity in the formula of everything, when it is being extended, then we have it as mass worth relatively to quantum energy worth. So that's why I use the mass worth here. Now, when you look at this definition quite all right, you will see that it actually explains the entirety of what mass could stand for, because here we have convergence, which is the formation of mass, and that convergence is as a result of its trajectory against repulsive interaction of time energy tapestry. And then by having that kind of repulsive force on that trajectory, I said in formula of everything that mass interact with energy inversely, and also time interact with energy inversely. Time also interact with mass inversely, and mass interact with time inversely. And it is for that reason that we have suspension of mass at the extreme edge, at the maximal point of time energy wave interaction, and also at the bottom, which is the minimum point of time energy wave interaction. So this definition is ideal for mass. It's ideal to actually illustrate, or it is ideal to describe mass. So now let's look at quantum gravity. Quantum gravity, this is defined as convergence towards the entropic divergence of mass worth through the compression of time energy tapestry to form energy density. So I'll just put form here to form. Let me rewrite this portion. To form energy density. Now, you will be able to understand this definition of quantum gravity quite all right by the time we get to time energy wave model. But if you look at this definition, this is more than enough to describe what quantum gravity is, because at the face of gravity, the gravitational wave of time energy wave model, we see that the trajectory of gravitation is toward the central 0 point, which is singularity, and also we have the trajectory of classical gravity and that of the quantum toward that singularity. And as a result of that, the shedding of mass, which is that phase is illustrating mass decaying of mass, And so the trajectory of that continuous increase in energy will shed mass, and it will be converted to what is known as energy density. So now, if you look at the definition, we have convergence defined as a convergence towards the entropic divergence of mass worth. That is the description of decaying of mass there through the compression of time energy tapestry. We can see that the time energy wave is being contracted toward singularity, and that is why we have this compression of time energy tapestry there. And the whole conversion of shedding of mass will be to form energy density. So those, mass definition and quantum gravity definition, they are ideal definitions to describe the two mechanisms. So now I will just clean this board and then draw the time energy wave model. So now let me quickly draw the time energy wave model. Okay. So here we have quantum mass. And here we have classical mass. This classical mass is way bigger than quantum mass. So they get entangled to each other. Here is evolutionary singularity, and here we have future singularity, or singularity of the black hole. Now this mass is being suspended, and we have this. Okay, so now this is time energy wave model. Now when you look at this, I'm not actually going to bombard this time energy wave model with values. I just want to explain the gravity phase part here. So when you look at the time energy wave model, we have the trajectory of time like this. It goes up and then down like this. And then we have the trajectory of energy wave relative to that of the time like this. So now what this is telling us is that when time scale wide, then energy becomes narrow. So in that kind of situation where we have low energy at this bottom, then we have convergence of mass, and also relatively to that quantum mass, we have a classical mass at the top there. So I just want to label this. This is a quantum level. And here is classical level. You shouldn't forget that formula of everything is meant to unify quantum mechanics to classical mechanics. So that is why we usually have classical level and quantum level. So now, the moment quantum mass is being formed at the bottom, we also have the classical mass being formed at the top. And you can see the trajectory of energy being reversed, right from energy decreasing to energy increasing. And when you look at what we have here, what we have here is synonymous to entropy. So it is synonymous to entropy, which is energy always increasing. And when you have energy increasing in a narrow space, then it will be decaying the mass worth of the entity that travels through the formation. So now, if we go back to that definition, you can see that we have quantum gravity. At this point, at this region, we're going to have the quantum gravity. We're going to have quantum gravity. That means towards the singularity point of the future, then we will have the merging of classical gravity to quantum gravity. So we can just fuse them together to have this quantum gravity altogether. But in my own context, I usually say we have classical gravity, and here we have quantum gravity. So now, if you look at this quantum region, the quantum region, we have time energy being contracted, and so that gives rise to acceleration. And as a result of having that kind of acceleration, then there is entropy. But if you look at the classical region, the mass is being suspended. There is no form of contraction, and so we have free fall right here. But the gravitational effect that we have at quantum level comes with speed. It comes with acceleration. So entropy, I don't know how to differentiate entropy from quantum gravity, because what this situation is narrating is entropy, and it is also quantum gravity, because we have the trajectory toward the singularity, and then when mass is being shared like that, we have it being converted to energy density, where I explained that in some of my previous videos. So if you watch them, you get to understand it better. But basically what I want you to know is that as we have the gravity phase going towards the singularity, then the intense of gravitation will be so vibrant in the black hole, because this singularity is the same thing as black hole singularity. So with this, you can have the clear picture of what is obtainable inside the black hole. So another thing I want you to know is that we can use what we have at this present phase. I usually call this gravity phase, I call it the future, and I call this expansion phase as the past. Why this middle point of entanglement of quantum mass to classical mass, I represent that as the present. So we have a very tiny present realization or reality, and so it seems as if we don't even really have the present as such, because as time is going forward, you see that events are retiring into the past, and then we are moving forward to grasp the event of the future, which will never exhaust. You understand? So basically, what we have here, we can use it to analyze what could happen inside the black hole. Now, definitely the classical mass that we have here, the worth of this classical mass will be more than the speed of light, as we know that light cannot even escape the black hole. So the decaying of both the classical mass and the quantum mass has to be converted to the energy worth that is more than that of the speed. so as to trap speed inside the black hole. So it has to be more than what the speed of light can exhaust. It has to be more than what the speed of light can actually traverse beyond. So definitely we have the phenomenon of FTL, which is faster than the speed of light. You understand? So we have it, and that phenomenon will be gotten from the mass worth of the classical mass and the quantum mass at this present phase. Another thing is that this present phase that we have here, we can liken that to event horizon, which is the boundary edge of the black hole. So we don't need to get into black hole to know what is happening inside the black hole. We can actually use the information we have at that event horizon, at that region of event horizon, to explain what would happen inside a black hole. So with that, we get to know that the phenomenon of faster than the speed of light is actually present in the black hole, and that is why the speed of light cannot even escape when it is trapped inside the black hole. And we have seen that too in a situation where we get the actual electron mass beyond the constraint of time energy wave polarization, electron mass. So by applying formula of everything, when you supply this mass worth of electron into the formula of everything, which is the T, the M, capital U plus 4. When you put this value in place of this M and this M, you are going to get the classical mass worth, the corresponding classical mass worth of this electron as 2,277,000. As